And this is our system in action, performing defect recognition in real time. Green when there are no defects, and red when there is some defect in some part of the product detected. Hi, welcome to this new video. I'm Sergio. I'm very excited about this video because I get requested this one quite a lot. We're going to see right now how to build a defect recognition system from scratch. We will see a step-by-step approach to build this system. Also, we will see how to solve most common problems. For example, when you don't have a lot of samples, but also another problem is dealing with low accuracy. So many developers try to build a system and they face low accuracy. So I'm going to show you a different approach to this. I will show you something very easy to implement, so also beginner friendly, that can be very reliable and accurate. You can apply this system on any conveyor belt where there are products passing by, so you can put a stable camera in front of the products and there you can do the inspection. In these specific video samples, we will be using these bottles. We will be identifying a few different types of defects. This is the bottle as it should be, without any defects. In this one, for example, the bottle is fine, but the label, we have some scratch on the label, and I produced this one, so this is some sample that we are using. If you don't have product with defects, you can make some defects, even some simple invisible ones, so that you can start building the system and later you can improve it with more type of defects when they come. Here is a bottle without the label. Then we have a complete wrong bottle right here. Another defect on the label. Here I put some marker sign and so on. Of course, these are just a few samples where we are going to focus on for this specific video, but you can focus on any type of defects, even more advanced, if there is also some change in the shade of the painting, some small, almost not visible scratches, the level of the water, and any type of defect that you see mostly common in the production. That's something that you can implement. And this one is, of course, the first step. You need to get samples. The video that I have is a video samples that I'm going to use because from the video we will extract all the data that we need to create our software to analyze the defects in real time. You need to record a video samples when you have like both type of samples. We have product with defects and product without defects. Don't worry, you don't need to have many samples, especially at the beginning, because it's hard to collect a lot of samples. I know because I've contacted many companies that are dealing with such systems, and that's one of the biggest problems. You can start with a small amount of samples. Then when you create the system, you make it in a way that you can update later the samples. You can get samples when they arrive, when you have more product with defects. If you don't have anything, maybe you can make it up. You can create some defects on some product and then you can use that to start building your own system. Record the video something similar to the one I have. You can use even a webcam, you can use a phone, it doesn't matter, as long as the product is well visible and the products are passing on a conveyor belt. Let's start now with the first step, and this is where many people make mistakes, is to try to, from the video samples, from the images, try to identify the defect right away. And that's not how you should do that. You should first focus on the product, because you need to remove all the background, all the noise possible to get high accuracy and to get focus on the specific product. Because they are passing on a conveyor belt, there is so much noise, there are other elements in the background, and if you try to detect the defects right away, then you are going to have a lot of false positives. Before starting to identify the defect, identify the product. And we can choose two ways to do this: either object detection, which means putting a bounding box on the product, or if you need something more advanced, object segmentation, if you need to remove more background. Now we're going to make this system very simple, so we only use object detection for many reasons. It's faster, it's easier, it takes less power from the machine to analyze, and so on. Let's do that. The process that we have to do now is an annotation process where we teach the deep learning model what a bottle is, what our product is, so that we can detect and track the product. And it's something like this, where we use an annotation tool where we give bounding boxes and then to each object, so that we can train our model to understand that. There are many online tools that we can use to do the annotation. I'm going to use RoboFlow. It's one of the most popular, where you can upload the video. From the video we extract images, and then manually we can do the annotation. Why do we need this process? So that we can teach the deep learning model what a bottle is. And for each image we make a bounding box for the specific object that we want to identify. In this case we can say bottle, and here we have the bottle, and then we do the same for the other one, bottle. And we can do this for all the part of our product that we want to identify. We want to check to inspect the bottle, so we do that for the bottle. We want to inspect the label right here, so we do another annotation for bottle label, and for this one also. Then if we want to inspect the cap, for example, we can do the same for the cap. For anything that we want to identify, we can do this. And of course, we need to do this process for all the images. So I have now 156 images. I've done this for the first image. We'll do the same for the second image, and so on. Of course, this is a long manual process, but it's necessary. It's necessary, and it's a very important, crucial part of the system to get the best accuracy possible. Start with a small samples if you don't want to take like days of doing these labels, because like 100 images, it doesn't take long to make, and then you can always improve it later. Then we proceed with the training. What is this step? In this step, we're going to take all the images with the annotation, which is the image dataset, and we're going to train a specific model. There are many models and it's evolving very fast. Now we're going to use the YOLO model for object detection. I'm going to use a specific notebook that I've created to make this process extra simple and fast. Jupyter Notebook. Let's now run this notebook for training our model. We select the project type. We have different types that we can use. We have classification, we have segmentation, and we have detection. This is object detection. We select detection, we initialize the project. We choose our model now. When I'm recording this video, it's YOLO version 11 medium from Ultralytics. And we're going to create our project, bottle detection. Depending when you check this, it might be a different version, but the structure is the same, no matter the improvement of the model, whether it's 12 and so on, it stays the same, just better models. We load our dataset, and then we proceed with the training. When the training is done, it doesn't take long. Depending on the graphic card, it might take from half an hour to 1 hour or a few hours if you have a lot of samples, like thousands of images. We get this file, which is called the best.pt, which is a file of 40 megabytes, which is the model there that will detect our bottle or your product in your case. Let's try that. I'm going to start from an empty Python file, and I'm going to show you the main course of this app. I'm going to do this fast. From engine, now we're going to do object detection, so we import object detection. We load the model. The model is the one that we just created, so on the model we need to put our file best.pt for our specific product, the one in this case for our bottle. So I put this already in the folder models of this project, so I just load it best.pt. Now let's load our video. We need a capture object, cv2.video capture, and here we put our video. We import cv2, which is the OpenCV library. Here bottle.mov I have. Now let's put everything in a loop so that we can load the video while true. And here the compiler is adjusting everything, so we have the image cap.read. Now before doing object detection, let's show everything to make sure that we're loading the video correctly. cv2.im show. Now of course I'm going fast with this. If you're not familiar with OpenCV, I have so many other tutorials about this. cv2 wait key to keep everything on hold. If we press 27, which is the S key on the keyboard, we want to quit, and then we release everything. Now let's run this. We're now loading the video correctly. As you can see, it's going to very fast. Let's now perform the object detection using the model that we've just created. So I'm going to close this one. And we perform the detection here after we get the frame. So we do object detection, and the object detection will be od.detect. We want to detect image Here are the parameters, and what are we going to get? With object detection, we're going to get bounding boxes, class IDs, and scores. Now let's loop through everything. Here the Copilot is suggesting this already. I recommend to write everything from scratch if you're new to this so that you can familiarize. We're getting the bounding box. Now let's do this simple, and we show the rectangle. We're getting the coordinates x and y, x2 and y2 to draw the rectangle about the position of our object. Let's test that. And now you can see this is happening now. We are having the detection of the three things that we wanted to detect it in real time from the video. And this is our model that's doing that. So the object, when are crossing on the conveyor, we have exactly the detection so we can extract our product. First step is done. We have the detection of our product. And this is very important that you do this well. If you have already problems with this one, if it's not detecting correctly the product, then you need to improve this one. Don't go further if you are not succeeding with this one. What's after object detection? After object detection, we need object tracking. There is a crucial difference between detection and tracking. When we work with videos for our computer, it's just a video, it's just image after image, frame after frame. We need object tracking to associate a univocal ID to the object so that we can keep track of the objects when they're moving. There are many algorithms for that. Let me implement this. So from engine.object tracking, we're going to import multi-object tracking, MOT equals multi-object tracking. We select a simple algorithm OC sort, tracker dot equals MOT dot OC sort. Also, this one that I'm showing you is an implementation that I made of this to make this very simple and straightforward. Now, from object detection, we take all the objects that are passing here and we apply the object tracking algorithm. Update tracker. Here we pass everything. Our Copilot should just already know everything. So tracker.update, we give the bounding boxes, score, class IDs, and EMG. And now we loop through this, through each track object. And we will have our object track. Now, you see almost everything as before, but there is a crucial difference that we have an ID above each bottle. This means that we have the object tracking implemented. You see now this one is 21. If I let it go, it's still 21. And that's important because we know that's the ID. So we track them only once because you need to inspect them only once. When they're inspected, then you need to let go. We don't need to operate all the time on a new image. And we're here at the second step. I already showed you the tracking part. So why do we track that? We track the products because we want to associate a univocal ID. Why do we want a univocal ID? Because we check them only once and we extract the part of the products that we want to identify. Now we do that. We put a line. So when the product crosses that line, we say, okay, now we identify the product, we extract everything. Let's do that. Let me first tell you why do we need to put a line. Let's say that the products are crossing. Now we have two products here. We have two bottles. One is ID 10. You see their ID 10 and one ID 5. There is 5 and 0, the one on the left. We want to identify the bottle when it's well visible, like the bottle 10, it's well visible, it's almost at the center of the screen. And that's the moment where we want to do the inspection. The one that's 5 there now, it's only half of the bottle visible. And if we don't say where to do the inspection, then we have the problem that's visible everywhere and we have their half bottle and that's a problem. We draw now a line. You can choose based on the product and what visual you have. We draw a yellow line in the middle of the screen and that's we say, okay, when the product reaches this line, let's do the inspection. Let's get center of the image. Here we have height and width of the image. Draw a vertical line in the center of the image. And let's now run this. We want that the products, when they reach this line, we perform the detection. Let's do that. We need to intercept that on the loop where we're detecting the object. Here is the loop where we have the X and Y of the object, of the bottle, of the label, of the cap. The X and Y is the top left point. The X2, Y2 is the right bottom point. Let's focus on the top left point. This is the X and Y point, X, Y, on each bottle. When this point reaches this position, we intercept. So we check how can we do that. We can say simply if the y is less, if the x is less than center x, so if this one is center x, if this value is less than this, it means that we are crossing the center. Very simple. If the x is less than center x, then what can we do here? If it's less than center x, okay, we don't have center x, center, and then let's take the first value. If it's less than center x, we want to extract the image. We want to extract the part where we have the bottle, where we have the cap, where we have the label. Because now that you're doing object detection to detect the object, let's take the object, and then later we can do the inspection in that one. We extract image, which is called array. We have a region of interest. That's what's happening now when it's crossing the line, and you see we have the image extracted. Now we have the bottle and we have the image of each part. And this is so great because once we have these images, then performing the inspection is much easier, is more accurate, because we're focusing on a very small part. We save all these samples right now. We create a new folder called inspection dataset. Then we can split this, because we want, of course, work separate with the general bottle. We want to have a separate inspection for the label. Otherwise, it would be a mess if we try to match all the defects all at once. We need separate model. We need things simple and organized to have this reliable. Bottle, label, and everything that you have. Now, when we detect them, let's save them into their own folder. So we can ask now here, save by class into a new folder. Here, each time we detect the image, we extract the image, we save it into the specific folder. The bottles will be in the bottle folder, the caps in the cap folder, and so on. In order not to repeat the saving, we have the ID, so we don't save the bottle, the same object 2 times. We need to keep track of that. Already saved, set, and then we add here already saved.add, and we add the object ID. Now, this is the crucial part of our inspection system, because that's where we're going to perform the inspection on these images that we just extracted. And now in this first step, we will see how to do that. We will train a classification model. We take the extracted images and we classify each of them. We'll see now step by step how to do the categories. For example, we take the bottle images and we can classify them into good or bad. And we can add multiple classes to categorize this type of defects. You can have scratch, marker sign, and so on, depending on the classification that you want to do. To prepare our dataset is very simple. We only need to take the images and put them in separate folders. In this case, I will show you how I did it for the labels. We have a folder which is called good, which shows the good labels. And here we have the labels without any defect. So when I scroll, there are labels without any defect on the good label. Then we have the labels where there is some defect, there is the marker sign, and all of them are in one folder. Labels with the scratches, and labels that are completely wrong. This is just to give you an idea of how to do that. Now we use the same notebook I used before. Now I do classification. Let's choose the project. I have the project now for label classification. The images are already there uploaded. We load the image. You see it found the image for class good, marker sign, scratch, and wrong. And then we do the training. And we repeat this operation for all the models that we want, for all the things of the product that we want to identify. In this case, a bottle label classification for the new project could be just the bottle classification or cap classification. And we put the caps images and so on. Once we have our models ready, we integrate that into our system and go at the beginning of the code. We import the module for classification from engine object classification. We import object classification, and here we do classification. Now I have the model for 2 things. For the bottle, is a bottle good or bad? And then for the label, we have 4 different classes of the label. We know if the label is good, it has a marker sign, it has some scratch, or if it's a wrong label. Class label equals object classification models label classification.pt. I have all the models put into the models folder, and then also class bottle object classification models bottle classification. Where do we do the classification? We do the classification as before, where after they cross the yellow line, then we check, is the bottle good or bad? is the label, good, bad, with marker sign, and so on. Let's do that. Here we get the image, inspect the object. If class name is label, then we have class label classify. It's doing everything well already here, the copilot. It knows already what we're doing. So if the class name is the label, then we want class label classify what? We want to classify the ROI, which is the image that we cut. And then we have the class ID. Let's print class name. And let's print also object ID. Print object ID. And let's print the class name for that object ID. And the same for the bottle. Okay, now we're having a real-time test of what's happening here. We are only printing them below. We don't see them yet in the screen because I haven't worked on the user interface. We see object ID 4. 4 is the label. So you see object ID 4 below and then class good. Object ID 8, class good. 11, it's good. We have also for the bottle, but it's above. Now we can display that later. Let's just arrive till a label where it's wrong. Okay. 33, good. It's the bottle. We don't see now the 34. 34 is bad. Let me see. Okay, 34, there is the scratch. We didn't show that one. Let's improve the user interface because it's not so clear maybe for you. I've just improved the user interface so that it's more clear. I put some code to change the colors. The concept now is when they cross the line, the object will be surrounded by green if it's okay, if it doesn't have any defects, or by red if it has some defects. So let's see this in action. And it's working. Now we have the label where there is the scratch. We have the red there on the label. The bottle is okay. Now we have wrong bottle, wrong label. We have both red. It's working here. And here we have the scratch. We have it red. And of course, now we're just displaying this, but we have also the class and we can display also on it the type of defect. We have already that one. As we can see on our output here, we have the object ID, we have the class, so the type of defect that is either good or marker sign. And with all of this information, we can do a lot of operation. We can save this into a database. We can save the image associated to the defects into a database, so we can keep these things organized. You can take some action. You can take in real time an action to stop the conveyor, to send some alert. There is a lot that you can do with this. And this was a simple overview and explanation of the entire process. Everyone can do this, even if you're a beginner. I have many beginners in the academy that they are starting from scratch and they are building system to inspect and to detect objects. All the material that I use for this course is inside the academy. You can find also online for free many open source resources. We use Ultralytics from YOLO, so the object detection model. You can use image annotation tools like RoboFlow, MakeSense.ai. Everything is out there. You need just to take action and start building your project. I hope that you like this video. Let me know in the comments if you have any feedback, if you want to see something similar to this, and I will read all the comments and take inspiration for the next content. This is all for now. See you in the next video.